Okay, good afternoon, everyone. My name is Patricia Rooney. I'm the project coordinator for the New Brunswick Federation of Woodlot Owners. Just to let you know, if you wish to listen to the presentation today in French, there is an interpretation button in the bottom of your screen. You can select English or French there. This webinar is being recorded and will be made available for viewing afterwards. You will notice that your lines are all muted. Feel free to type out any questions you may have at any time during the presentation in the little chat window. But please note we will be addressing all the questions at the end of the webinar during the Q&A session. So today's webinar, the answer is Blowing in the Wind, a conversation on wind disturbance in the Acadian Forest of Eastern Canada. It's the fourth in an informational series for woodlot owners and forestry professionals in relation to climate change adaptation. This webinar series is part of a project called Building Capacity of New Brunswick Woodlot Owners to Adapt to Climate Change, which you can learn more about on the Federation's webpage, www.nbwoodlotowners.ca, or by following us on Facebook. The project is supported by funding from Natural Resource Canada's Climate Change Adaptation Program and the Government of New Brunswick's Environmental Trust Fund, as well as through work by our project partners, Community Forests International, University of New Brunswick, and the New Brunswick Department of Natural Resources and Energy Development. Today's presenter, Dr. Anthony Taylor, is a research scientist with Canadian Forest Services. He received his PhD in forest ecology from Lakehead University. He's published numerous papers, with his current research focusing on modeling how climate change will impact forest regeneration and growth following disturbance, and how to adapt our forests to future climate challenges. So without further ado, I'd like to hand things over to Dr. Anthony Taylor. Oh, Anthony, you're muted.
Hi, Patricia. Sorry about that.
There you go.
Do you mind if I just wait just a few? I just want to wait a few more seconds here, just to give participants another few seconds to connect. I was just watching the attendee number there.
Yeah, a few people are late, but that's okay.
Okay. Anyways, okay, I'll get started then. Well, thank you everybody for who's tuning in this afternoon to this talk. It's much appreciated. And thank you to the New Brunswick Federation of Woodlot Owners for inviting me to give this talk today. I do notice today, at least here in Fredericton, it's not that windy out, which is unusual for here in the Maritimes. So I guess really when you think of it, there's no maritime that hasn't been affected by wind to one degree or another. You know, whether you work in the woods or in your day-to-day life, wind is as much a part of life here in the Maritimes as black rum and fiddle music, you know, just to keep that cliche going a little longer. And I guess that's why they call it Canada's stormiest province, or stormiest region, that is. Although Newfoundland might have something to say about that. And, you know, and the fact that wind is such an important part of our lives here, it really hit home to me a few years ago when I moved to central Canada, northwestern Ontario in the prairie provinces. And although the folks up there have wind, they don't have the same sort of perpetual wind that we seem to have here, especially if you live closer to the coast, which just sort of happens all the time. And what I noticed was how much I missed the wind. Like you don't realize it, I guess, till you leave your windy home and go somewhere where there's less of it, and you sort of miss that going out in the morning and feeling that breeze or blowing your hat off or whatever sort of thing. So we live in a windy place, and we're probably all the better for it. And you know, we've all experienced wind events, severe wind events from one extreme to another. And just to go over a few to get us all in the mood for wind. Some might remember here in southern New Brunswick a few years ago in 2014 when post-tropical storm Arthur came through the region and caused quite a bit of damage. Actually, I think it was a record for New Brunswick Power at that time in terms of damage caused from a single storm. And this picture here is a few pictures I took outside my home in Fredericton, and That's an old growth hemlock in Odell, snapped off of the base. And my dairy farmer uncle from the prairies, who hadn't seen anything like that before. And, you know, and our home at that time, we lost power here in Fredericton for about 9 days that day. And so we did a lot of this. I don't know if you could see my mouse or not on the screen, but in that bottom picture there, the Coleman stove did a lot of work with beans and wieners that week. Another wind event some might remember is the Hurricane Dorian that went through in September 2019, just a couple years ago. That hurricane, it touched base in central Nova Scotia, and the system made its way through central Nova Scotia, and it affected southeastern New Brunswick and PEI. And these pictures here are taken from Cavendish Beach Park and PEI National Park from last year. We were over there taking a look, and I spent a lot of time growing up going to this park and camping there. And I'm not sure how many of you have done the same, but this bottom picture here actually is a picture where it used to be all white spruce there. We used to have campsites within amongst the white spruce, which made it so nice. But Dorian went through and finished that off. So that's what it looks like today. Just Patricia, I have one quick question. Can you see my mouse if I'm moving it around?
We can actually.
Okay, perfect. But it was the big one that someone remember, Hurricane Juan in 2003, that really affected a large area and a lot of people. Hurricane Juan made landfall in Nova Scotia on September 29, 2003 as a Category 2 hurricane with sustained winds of 158 kilometers an hour, wind gusts up to 185 kilometers an hour. So it's pretty powerful winds. And, you know, it lost steam as it traversed north across the province and it made its way into the Northumberland Strait. But the storm lasted about 3 or 4 hours and it affected over 1 million hectares to forest area in Nova Scotia. And it was the big one, Hurricane Juan, that got me interested really in this question of wind and wind throw and wind disturbance. And this picture here is, I grew up on a woodlot in the Musquodoboit area in Nova Scotia. And over the last 30, 40 years, I worked with my family, my father, on the woodlot, doing a lot of, you know, single tree harvesting, small group selection type management, you know, partial cutting sort of thing. And we tickled the forest there and took a lot of pride in that forest. But then within about a 3-hour episode on that evening of September 29th, 2003, it ended a lot of our hard work. And so this is a picture actually taken after the storm in 2004, showing, well, some of the blowdown areas and clear cut areas that we did a lot of the partial cutting in. So it was during that time working, you know, and in the woodlot afterwards, cleaning up and salvaging, and then also in subsequent years, working in Nova Scotia and central Nova Scotia, cruising and evaluating some of these wind blown areas, that I started to ask myself, you know, what makes a woodlot vulnerable to wind throw? Like, why is it, for instance, in our own family woodlot, these areas here blew down and these areas didn't? And, you know, and this question was evident across the region, that area where Hurricane Juan went through. You know, what are the factors that drive whether or not, you know, one tree blows down, one tree doesn't, and that sort of thing. You know, and so I was quite interested in that question. But it wasn't until I started in this current job, you know, in 2011 and a little later, that I actually had the opportunity to begin to look into this question a little bit deeper. But, you know, at the time when I started looking into this question, one thing I noticed though was that there was, as windy as the Maritimes is, there was little research done on wind throw. And just a quick search before when I was making this talk up, you know, at the time when I was making the talk, when I look at a search portal like Google Scholar, for instance, there's like currently I could find less than 10 peer-reviewed science papers on the effect of wind throw on the forest in the Maritimes, you know, which is not a whole lot. And to put that in perspective, I could easily find greater than 40 published papers on the effect of spruce budworm on the forest and the Maritimes, with a lot of those papers being done through the lab of Dr. David McLean. And so why is this? Is it because spruce budworm is that much more prevalent than wind and wind throw? No, I don't think. And this answer really came obvious to myself and others over the past year. Myself and Dr. David McLean, we worked with a group of experts from the Department of Lands and Forestry in Nova Scotia to conduct a thorough literature review and synthesis of what are the primary disturbance agents affecting the province of Nova Scotia. And there's one thing I should point out too in this talk is a lot of the work has been done in Nova Scotia, and just where it so happens some of the work I've been doing has taken place, but it has direct implications for both PEI and New Brunswick, as we're right next door, and the Maritimes is not that big of a place. So anyways, it was during this this literature review, this review work that we did starting 2 years ago, where we looked at over 300 years worth of documents and reports and current quantitative data, and determine, well, what are the primary disturbance agents that affect the forest of Nova Scotia, which would affect the forest of New Brunswick and PEI as well. And what we found through that work was that overwhelmingly there was the big three. That was wind, spruce budworm, and fire. And fire being something we don't maybe think about as much today, but before fire suppression and European human influence, fire played a bigger deal than we realize. Anyways, the big three cause more than 80% of the tree mortality that we experience here in our forest in the Maritimes. Now, it's not to say there's not other disturbances that affect our forest, and I have a list of them right here on the slide. For instance, there's other insects and diseases that are important that affect and kill trees in our region. And there's other disturbances such as ice storms, droughts, floods, temperature extremes, for instance, the influence of mammals such as beaver and whatnot. And all these things are important and influence our forest, but not to the same degree as these three up here. And I would argue for a lot of the province, not to the same degree as wind itself. And just to put that into context, one hurricane can kill more trees in a 3-hour period than 50 years of spruce beetle damage in the region. So when one of these big wind systems goes through, they can kill a lot of trees. So it's a very important disturbance in this part of the world in terms of affecting the forest. And because of this, we know that wind is a key driver of forest dynamics in a region. High intensity winds are influence and cause stand replacing dynamics, and low intensity winds drive gap dynamics in old forest. We see this firsthand. And another reason why understanding wind and its influence is important is in the region, actually across jurisdictions across the continent, but there's a move in philosophy of forestry from sustained yield production-based forestry to a more ecological forestry, they call it, where the philosophy is the maintenance of natural ecological conditions within which the sustained yield of products to meet human needs is achieved. And these natural ecological conditions are more likely to be achieved by management practices that emulate natural disturbances. So at the core of ecological forestry is this idea that we should try to emulate, copy, what nature does through natural disturbances. But the success of this management approach largely depends on, well, how well do we know these natural disturbances and their characteristics? So that just gives a bit of a primer of why wind is important to our region and why we should study it. And for the rest of this talk, I'd like to hit on 5 sort of key points. The first one being, I'd like to cover some key concepts when studying natural disturbance ecology that I think it's important actually for all of us to know to some degree, but especially woodlot owners as we think about our woodlot and how disturbances affect our woodlot. Then I'm going to get into a little bit more specifics on wind and windthrow itself. And then what are the primary agents that drive windthrow in our region? Then what are the factors that predispose woodlots to windthrow? So for instance, what factors influence whether or not how wind affects our woodlots? And then lastly, I'd like to end off with, well, how will climate change affect future windthrow in our region? And okay, well, this is a very wordy slide, but it's an important one. And these are these key concepts I was talking about in regards to natural disturbance ecology. So when studying natural disturbances, there's some definitions that I think are important to keep in mind. And the first one being itself, well, what is a natural disturbance? And I'm just going to read the definition right here. Any relatively discrete event, such as a burn or a windthrow, that disrupts the physical structure and resource availability of an ecosystem. And this is based on a definition of natural disturbance that was made popular by Peter White and Stuart Paquette back in 1985 in one of their a well-known textbook. And it holds today. So a relatively discrete event. But within the realm of natural disturbances, we have different disturbance agents. And what is a disturbance agent? Well, a disturbance agent is a particular driver of a natural disturbance, or cause or catalyst of a disturbance. So for instance, fire or wind or spruce budworm or another insect, those are the driver or the agent, we say, of the natural disturbance. And then we have this other term here, natural disturbance regime. And what a natural disturbance regime is, it's the average behavior of a disturbance agent over a defined time period characterized by key disturbance variables. So it's a way of describing the behavior of a particular type of natural disturbance. And these variables are an important part of this definition. And there's 3 of them down here. And these variables we use, or parameters, if you want to call them that, we use to describe the regimes, these natural disturbances. And these 3 here are probably there's different ones used, but these are the 3 core ones that you'd see across the natural disturbance literature. And what they are, and I'm not going to get into too much detail with them, but is spatial extent is the first one. So when describing natural disturbances, what is the total area roughly that usually gets affected when a disturbance goes through? So when a hurricane goes through, what, like, is it small scale? Does it affect 3 hectares, or is it large scale? It typically affects thousands of hectares. That's the spatial extent. The second variable is severity. So this variable is, well, it refers to the total amount of tree biomass killed per unit of forest area during a single disturbance event. So when a disturbance such as a hurricane goes through, how much wood per unit area does it kill? And when a hurricane does go through, it doesn't necessarily cause like high severity disturbance everywhere. Across the total spatial extent, there's areas that receive high severity disturbance where greater than 60% of the trees are killed. There's areas that receive moderate level disturbance, and there's areas that receive low level disturbance, say less than 30% mortality. So high, moderate, and low in terms of severity. The last term that I think is really important to understand when talking about natural disturbances, and sometimes I think it's the trickiest too, and I oftentimes have trouble bending my head around it, but is this idea of return interval. And essentially what a return interval is, it's the time elapsed between successive disturbance agent events on the same place on the landscape. So if you're standing out, we'll say you have a particular stand in your woodlot, what a return interval is, and we'll see this number come up in the presentation more, but what it is the average amount of time it takes for that spot in your woodlot to be disturbed again by the same disturbance at a particular severity level. Or put another way, is that the return interval, that time period, say if the return interval is 150 years, it also means it's the time it would take for an area equivalent in size to the landscape that you're talking about to be disturbed by that disturbance. And so some examples of this will come up. So just a few more definitions, and then we'll move on to some pictures and graphics. So in terms of now, we've talked about more generally natural disturbances, but in terms of wind and windthrow itself, well, what is wind? I mean, we all say wind. I'm sure that there's a technical definition, and there is for sure. Wind is the bulk movement of air along the Earth's surface in response to atmospheric temperature and pressure gradients. So now, when you have areas of air that are a higher or lower pressure, air will tend to move from high pressure to low pressure. And it's that movement along the Earth's surface that is what we're experiencing, is the wind, the movement of the air. And one of the main attributes of wind that we're usually most concerned with as citizens, but also as ecologists and and foresters, is wind speed itself. And generally, when we talk about wind speed, whether it be you're listening to the weather at night or using it in your work, we talk about maximum sustained wind, which is usually like the average maximum wind speed measured over either a 1, 2, or 10-minute time frame, depending on the agency or who you're talking to. Or we also talk about maximum wind gust, which generally refers to like the maximum instantaneous wind speed experienced or observed over a defined time period. So the maximum wind speed, not the average. So maximum sustained wind and maximum wind gust, two important metrics when trying to understand wind intensity. And then lastly here, well, then windthrow. What is windthrow itself? Well, windthrow It's the overturning of trees caused by wind, whether it be stem breakage or uprooting. And it's also known as blowdown, windfall, or wind blow. It's another term sometimes you used here for it. So that's what windthrow is. But if you want to understand a bit more, well, then, what causes windthrow? Why do trees blow over? Well, you can really get down into some deep physics about this, but these two diagrams here, I find kind of summarize it up nicely for myself. And I think also too for the average woodlot owner. And so when it comes to whether or not wind will blow down a tree, it's this tug of war really that's taking place between two sets of forces, what we call applied forces on one side and resisting forces on the other side. And the applied forces refer to, well, the wind itself that's pushing on the tree and pulling on the tree, but then also gravity, because these trees have mass, and as a tree leans over, then gravity is going to be taking more of an effect on the tree. And these forces, these applied forces, cause torque on the tree stem and the tree ball and the ground. So you have this applied force taking place, but on the other side of things, then you have resistance in the tree itself, whether it be the wood strength or wood elasticity of the tree, or the stem thickness of the tree, or the soil and the roots interface itself, like the nature of the rooting habit of the tree, the type of soil that it's in, how deeply it's rooted. These are all resistance forces. And it's this tug of war between these two things that will determine whether or not your tree blows down. So now we talked about what wind is and what windthrow is. Well, what are the main agents of windthrow? We know that wind causes windthrow, but in your everyday life, there's many sources of wind events. Well, what does wind come from? How do you even organize that? And there is a way to organize it. And the way that we organize it as ecologists anyways, is through looking at the meteorological origin of the wind and also the wind intensity. And I'm referring to the wind speed in this case. Now, we organize, we've generalized it actually down to two very broad groups of wind agents in our region: windstorms and hurricanes. Now, that might be blasphemy to meteorologists, but for the sake of application and practicality, this is what we need to do. And the reason why we generalize it to these two broad groups is because, well, hurricanes really stand out as their own beast in our region. Windstorms are a broad category of basically just non-hurricane wind events, and they include various wind agents that originate from different meteorological origins, and they include extratropical cyclones, tropical storms, and convective storm cells such as downbursts and tornadoes, to name some examples. And then hurricanes being the other broad group. Hurricanes are tropical cyclones with greater than 104 km/h sustained wind speeds, and that's the 10-minute maximum sustained wind. And hurricanes are typically measured on an intensity scale called the Saffir-Simpson scale, which is the SS scale. And so when you hear of like Category 1 or Category 2 hurricanes, in the weather or news, this is the scale that the literature is referring to, and it's referring to the intensity of that wind, the wind speed. Just to dive in a little deeper on windstorms. So windstorms, like I said, we have a number of different types of wind events that are included in this group of windstorms. But the biggest one that causes probably the most windthrow for us in our region is this group of wind phenomenon called extratropical cyclones. And these are basically weather phenomenon that develop at mid-temperate latitudes over the coastal US and sort of work their ways northeast towards us. And another common name for them is nor'easters in our regions. And the reason they call them nor'easters is because the wind that we experience from these low pressure systems when they come through and bother us, at least along coastal areas, is it comes from the northeast. These events tend to be the most intense during between November and March, but we receive them all year round. And on average in our region, in the Maritimes, we typically experience about 40 or 50 of these extratropical cyclones moving through our region in a year, but less than 2% of them are actually intense enough to cause severe windthrow. So some notable examples of extratropical cyclones that have affected us over the years include the Groundhog Day gale of 1976, which caused significant damage through southwestern Nova Scotia and New Brunswick with gusts up to 188 kilometers an hour. The Christmas Mountain blowdown of 1994, which would be in the memories of many New Brunswickers, had wind gusts greater than 130 kilometers an hour and damaged over 12,000 hectares of woodland. Or even White Juan, which occurred just after Hurricane Juan in February 24, that dropped a record-breaking 95 centimeters of snow and had sustained winds of 80 kilometers an hour. So these are some examples of extratropical cyclones that were quite powerful that, again, would blow down trees in our region. But in order to quantify the effect of windstorms on our forest, just in the last few years, we carried out an analysis, and it was related to that review paper I mentioned earlier, where in the province of Nova Scotia, because this is where the work was directed to, but it would have direct application to New Brunswick here as well. We use their permanent sample plot system, and they have quite a few permanent sample plots down there, and that's these little yellow dots on the map, and they're measured over time, repeatedly measured. And we took a subsection out of these plots, and we looked at the change and trees being blown over due to wind events on each of these plots. And through some analysis, we were able to determine sort of the average amount of windthrow that occurs from windstorms. And when we summarize these data, what we came up with is that high severity windthrow, where you have greater than 60% mortality of storms, occurs in Nova Scotia at a return interval of about 2,500 years. So every 25, at a spot on the landscape, on average, every 2,500 years, you would have severe windthrow taking place due to a windstorm. Moderate severity windthrow, where you have 30 to 60% mortality, occurred at about 263-year return interval. And low severity windthrow, where you only have 5 to 30% mortality, occurred at a much higher rate at every 14 years. And so what that means, again, is that, like, on average, at a single point in the landscape, every 14 years, a stand would experience a low level amount of windthrow, 5 and 30%, due to windstorm activity. Hurricanes. Well, Nova Scotia experiences more hurricanes than any other Canadian province, and so it would experience more than New Brunswick, but New Brunswick wouldn't be far behind because of its vicinity, of course, to Nova Scotia. But just in terms of Nova Scotia, the province between 1900 and the present day experienced over 17 hurricanes. And so this map here shows the path of hurricanes over that time period and the dates and names associated with them. So there were 17 hurricanes that made landfall. Now, these are not hurricanes that turned into tropical storms before they made landfall, because those would have been put into the windstorm category. But these are actually hurricanes that made landfall over the province at hurricane strength. So it turns out to be on average about one hurricane every 7 years. And so in order to, though, the issue with hurricanes is that although we get a lot of them, we haven't necessarily done a good job over the years of recording, like, the amount and types of damage in the forest that have occurred from these hurricanes. But luckily for us, after Hurricane Juan went through, which was quite a significant hurricane in 2003, the province of Nova Scotia invested quite a bit of money into doing an inventory, an intense inventory of how much area blew down, forest area, from Hurricane Juan. So in this figure here of the Maritimes, this black area that you see here with my mouse, this area the province acquired satellite imagery for and aerial photography, and they were able to delineate and determine the amount of area that was blown down at different severity levels from Hurricane Juan. And so at the time, back in the early 2000s, they used this mainly just to get an inventory of, well, what blew down, what was left. And I knew this data existed, and it wasn't until when I started my current job, I asked the province if I could use it, because it seemed like a good data set for trying to better understand some of these other things about wind. And one of them more recently we used this information for was to try to determine, well, what is the rates of windthrow that occur from hurricanes. So using this great data set, we're able to determine that on average, high severity windthrow from hurricanes occurs on a return interval of about 1,250 years, where moderate severity windthrow from hurricanes occurs at a return interval of about 714 years, and low severity windthrow occurs at a return interval of about 1,111 years. But this rate down here is probably very underestimated, because this figure comes from the data inside this area here, but it's likely, though, that some low severity damage did occur outside of that area, so the interval could be shorter than that. But nonetheless, it gives us a good starting point in terms of trying to understand, well, how much windthrow does occur from hurricanes on average in our region. So the last couple slides on windstorms and hurricanes give us an idea of like, well, how much wind throw occurs because of these wind activities. But then now, what about in our own woodlots? What factors then in our woodlots predispose them to being blown down from windstorms? And there, numerous research has been done on this topic over the years, in other parts of the world. And when you look at that literature, there's sort of four main categories of variables that come up and trying to determine this. Meteorological variables influence, whether or not your woodlot blows down, such as wind speed itself, wind gusts. Topographical variables such as elevation, slope, and aspect. Soil variables, and stand structural variables themselves. So you have many variables that contribute potentially to, whether your woodlot will be affected by a windstorm or not. But how important, or the relative importance of these, is still not clear, especially for our region and our forest. So just to back up here, so again, using that same data set from Hurricane Juan that was put together by the Department of Lands and Forestry in Nova Scotia, then I took that data and we used it then to, like, within this area of Nova Scotia, we know that there's areas that blew down, areas that didn't blow down. And so I wanted to know, well, then what factors of this list are most important in determining whether or not a woodlot would blow down or not. And so we used some various statistical analyses to test for a relationship between incidence of blowdown, rates of blowdown, versus this list of variables. And what we found was the most important variable of all was wind speed itself. Wind speed itself explained more than 80% of the variation in wind throw that occurred across that region. And I should just point out, this red line here was the path of the hurricane itself, the eye of the storm. And this area here is the main wind field of the storm that affected the forest. But across this area, even though we have a hurricane going through, there's a large gradient in wind speed. Closer to the eye of the storm, you have higher wind speeds, but when you get farther away, you have lower wind speeds and variability within between. So it provided quite a wide gradient in wind speeds to look at the effect of wind speed on whether or not, forest blew down. So when we looked at the data and we tested this, we found indeed wind speed was very important. It explained greater than 80% of variation in wind throw. And what was more interesting was what we found was when you have instantaneous wind gust occurring at 130 kilometers per hour, or sustained wind speeds of 95 kilometers an hour, then you have on average a greater than 50% probability that your stand of wood is going to suffer severe wind throw. So when you have those kind of winds on average, across your average type of stand, then you're going to experience significant wind throw. When you get up to more than this, so just as an example, if I go over to this graph here, sustained wind. So this is sustained wind speeds, and this is probability of blowdown. And you see this nice sigmoidal relationship that takes place. When you get up to sustained wind speeds greater than 120 kilometers an hour, well, then you have a pretty high probability that on average your forest is going to suffer from high severity wind throw. The second most important variable after wind speed itself was what kind of seems obvious, but was stand height. The height of the stand was explained a lot of the variation that we saw in wind throw, where shorter stands, of course, are less vulnerable to being blown down than taller stands. This 3D graph here on the side, it's showing tree height, average stand height on this variable, and then wind speed on this axis here, and then probability of blowdown again. And what we see is as height increases, well, then you have an increased probability of blowdown, but that relationship, of course, is affected by wind speed. And so even if you have winds, very high wind speeds, to say of 140 kilometers an hour, sustained winds, the probability of blowing down short stands, less than 10 meters tall, is pretty low. But once you get above that threshold of 10 to 15 meters in height, then the probability of blowdown increases a lot, especially with wind speed. But the most interesting variable of the analysis that come out of it, I thought, was after wind speed and height itself, forest composition was then the next most important variable influencing whether or not a forest stand blew down. More specifically, what we found was that high spruce fir content really increased the vulnerability of a forest stand blowing down, where high hardwood and pine content, if you have more hardwood and pine in your stand, it decreased the vulnerability of that stand blowing down. And this is really supported by other studies and literature who've done such work, such as David Foster at Harvard University, who's also looked at hurricane effects on forest in New England. So that was an interesting find just to see that. And I guess the reason why it was so interesting for me is prior to doing this, studying this work, when I was working in the forest in Nova Scotia, you'd see this firsthand. And this picture is a picture from down by Muscataba Harbor area and towards Nova Scotia's eastern shore. The area would be very similar to along the Fundy shore here in New Brunswick, with a lot of red spruce and granite soils, very rocky. And this is a place that was hard hit by Hurricane Juan. And you see this selective weeding taking place from the storm. So this place experienced some heavy winds, and there was a heavy spruce component in there, but the wind completely demolished most of the spruce. And you'd see this across the landscape all over the place, like, remnant white pine. They were obviously much able to resist the wind than the spruce and fir that were in there. So those are some of the factors that we found that were really important in determining whether or not stands were affected by wind. So what are some of the silvicultural implications? Well, to begin, I guess what we found, what others have found, is that if you're in an area in a situation where you have a woodlot and you're going to experience sustained winds of greater than 95 kilometers an hour, then you could say you're almost SOL. You're out of luck, because it's very likely then that no matter what you do to your stand, unless you've got a stand of 6 meter trees, you're going to experience some severe wind throw. So that's, I guess, one implication for silviculture. The second one would be, and this is obviously very obvious, is that taller trees are more susceptible to wind throw than shorter trees, but especially slim trees, trees that have a high height to diameter ratio. So that's nice to know, but we're not going to stop growing tall trees. I mean, that's our goal, is to grow tall trees. So then what can we do? Well, from our work and from others, then this fact that species composition matters is an important component to consider here then. And what we found in these maritime forests was that the higher the hardwood pine content, then the more resilient the stand. So a lot of the hardwood trees and the white pine trees were quite resistant to wind. So those trees are resistant themselves, but even stands with the high content of those species in those stands are more resistant. And then if you have those hardwood pine in stands, your spruce and fir tend to be more resistant because they're protected by those standing trees. So composition comes into play. So that's nice if but what about those people who have spruce dominated stands, or that's what you want to grow? You want to grow spruce stands. Well, if that's your goal and if that's the case, well, in that case, then I think in the Maritimes, then you got to be careful. And I say that when, if you're doing things like commercial thinning or some type of regeneration partial cut, then you really want to be careful on how much basal area you take out. Like, I see different numbers thrown around in the literature, but I'd say, you want to err on the side of no more than a third of basal area removal when working with pure spruce stands in this region. But again, this depends on the height and the height diameter ratio of the trees within the stand you're working with. If it's a stand full of skinny trees, well, then you might want to take out less. And if they're shorter and greater taper, then take out more. But it's also influenced by site exposure and soil characteristics. This figure here is from Tim McGrath's forest management book in Nova Scotia. And it's a nice figure just showing, different situations in the landscape where you have more exposed situations and more protected situations. So if you're in one of these more exposed situations with a spruce stand, I would really hesitant to take anything out. But maybe if you're in one of these more sheltered areas, well, then there might be more opportunity to thin more of the stand. And the same goes with soils as well. In the area in Nova Scotia where we did that work, where I was showing those previous pictures, we have areas where you have deeper mineral soils like this that provide better drainage and anchorage for the trees. But then you have areas where you have shallow, stony soils like this, which provide less anchorage, less resistance to wind throw. And so these are factors that need to be taken into consideration. And there are some researchers out there, two of them noteworthy here, Bruce Nichol from the UK Forestry Commission and Stephen Mitchell from UBC in Canada, who've done a lot of work in this specific area and who are worth looking into to understand this better. But at the end of the day, if you're a woodlot owner or working with silviculture, considering, how should I cut or manage my stand in terms of wind, I think you should really come back to this figure and think about this tug of war, because it's this tug of war, again, that's taking place between the applied forces and the resisting forces that will really determine, how susceptible your particular stand situation is to the types of winds that we might experience. So I'm almost done here. I'm just going to end off with with the last point, which was climate change. So then, well, how well then we know that climate change is occurring and it's going to continue to occur, and how will that affect then wind and windthrow in our region? This figure here is a figure I've shown different times in talks in the region on climate change, and it's showing well, the change in mean annual temperature for our region from the past, from 1850, where we have good records, all the way up to the present, and then two projection scenarios. The blue one here being the more optimistic Paris Climate Accord type of projection, RCP 2.6, where we get things under control relatively quick, quite optimistic now, or the more pessimistic or business as usual scenario, RCP 8.5, where we continue emitting greenhouse gases at rates we're doing today. And this is the sort of the magnitude of difference in mean annual temperature we can expect over the next, well, next 75 years in our region. So quite a difference in temperature. So that's obviously that change in climate is going to have an effect on the wind that we experience. So how will that change in climate then affect windthrow? Well, I have one slide on the effect of climate change, and so I don't know, that's a disappointment for those maybe expecting more on this. But the reason why I just have one slide devoted to this is because when it comes to wind, it's so uncertain. But just to back up, if we're trying to understand how will climate change in the future affect windthrow, the first thing you need to look at then is, well, how will climate change affect wind? But more specifically, how will it affect those wind agents that we talked about, windstorms and hurricanes? And so, well, when you look into the literature, the scientific literature of climatologists and researchers who study this, like here's some examples of papers here, what they find in our region or in this general Eastern Canada, and when you look into the future under these climate change scenarios, under that RCP 8.5, that more severe climate change scenario, there's the potential for an increase in the frequency and intensity of windstorms that we experience. So more of them and more intense one. But it's potential, you know, and under the worst case scenario, RCP 8.5, by the end of the century, a potential increase in 10 to 20%. But all these studies or the climatologists that I've talked to, they really err on the side of caution when they come to this. And the confidence in this, I would say, is on the low side. And it's just because it's a very difficult topic to try to understand and predict. When it comes to hurricanes, these guys at the National Oceanic and Atmospheric Administration, the US, NOAA, are sort of the leaders in this area and do a lot of research in this work. And when they look at projections of climate change for our region in the North Atlantic and in the hurricane season, what they suggest is that there's the potential for an increase in the intensity of hurricanes coming north, but not necessarily the frequency. So we won't necessarily see any more hurricanes coming north, but the ones that do come north may tend to be more intense. So, you know, the ones that turn into tropical storms that we get now, well, maybe some of those may actually last to become Category 1 hurricanes when they make landfall. And we might see more Category 2 making landfall. But again, even these guys, and if you go look at this yourself on their research papers or on their websites, they really err on the side of caution, and currently their confidence in this change is on the low to moderate side. So, but nonetheless, if you take these together and you do say, well, their wind from these events will increase, you know, in the years to come, well, then how will that affect windthrow? How will that translate into windthrow? And so you'd expect then there would just be more windthrow. But again, it's not that simple when it comes to predicting future windthrow. And there's a couple of important interactions to consider. And the first one here is that as the climate continues to change over the coming century, there's also projected to be corresponding changes in tree species composition. A researcher at UMB, Charles Bork, has done a lot of work in this area. And what he's found is when you're looking at the future climate and the tree species that are here, some of them become less suited, maladapted to the climate, and there'll just be less of them. And so even though, and those tend to be the spruce and fir, the more susceptible to wind. So even if we do get an increase in wind, if we have less of those more susceptible trees like spruce and fir, well, then maybe the net effect is really no difference in windthrow if we have more of the more resistant, more adapted species like the maples coming in. So that's just an important interaction that we have to take into consideration when trying to project ahead, how will climate change affect windthrow into the future? Another important interaction to take into effect is that wind doesn't work in isolation. It typically interacts with other disturbances, such as drought, insects, and pathogens. And so as the climate continues to change into the future, it's obviously going to have effects on drought, other insects, new novel insects, or pathogens. And so those things themselves may more adversely or less so affect trees, which will influence what trees are more susceptible to wind. You know, trees that are infected by pathogens or tend to be affected by insects like spruce budworm then tend to be more susceptible to being blown over by wind. So it's another another layer of the onion to try to understand when predicting into the future and how climate change will affect Windthrow. And so that's why in this slide, I basically started off with saying it's highly uncertain. So lastly, in terms of overall conclusions with this question of climate change effects on Windthrow, I'd say there's the potential increase in the frequency and intensity of wind agents with climate change, and therefore a potential increase in Windthrow. But the confidence in this at the time, I would say, is low to moderate, because the effects on Windthrow will depend on many interacting factors themselves. The only thing I could say you could have high confidence in will be that wind will likely continue to play an important role in all our lives here. As sure as there's fiddle music and black rum. Maybe you might really need the black rum. So that's it, Patricia, in terms of slides.
Well, thank you, Anthony. That was very interesting. Now, I'll give Anthony a chance to take a drink before we bring in too many questions. There is a raise hand button on the bottom of your screen you can choose, and I can unmute you, or you can feel free to type any questions into the chat box. We already have a couple, so I'll just give you a second.
Yeah, I'm fine. I'm good to go whenever you're ready.
Okay. So first one, and I apologize, I'm probably going to pronounce this wrong, from Gigi or JJ, says that they like the presentation and they wonder what benefits can wind bring to our forest ecosystem.
Well, that's Gigi, who I actually know, and yeah.
Thank you.
Well, in terms of benefits to the forest themselves, it's not a question I've really thought about too much, because often I'm always thinking of the dire consequences of wind. I mean, when I think of like the benefits of wind, I think about renewable energy and that sort of thing, but that has less to do with the forest, except for maybe the more wind we have and the more wind generated electricity, the less reliance on biofuels from the forest. But in terms of direct benefits, Gigi, I can't really think of any at the moment, but I'm sure you and I will have a chance to talk about this after at some point.
Okay. Next question is from Justin Weir. Are trees with tap roots versus a fibrous root system a variable in resistance forces?
Well, I would say that if the root with the fibrous diffuse roots, if it's a type of tree species that tends to have an architecture where it roots deeper with those fibrous roots, well, then it would be less susceptible to Windthrow than spruce, which again has a fibrous root system but tends to be a shallow rooter. So like the root architecture morphology, whether it's a deep root or not, it makes a big difference. But adding a taproot again would add more stability to it again. And so I would say, tree species with a taproot would be less susceptible, at least turning over at the root ball. But again, you also have to consider the stem itself and the strength and elasticity of the wood.
Oh, Justin, thank you. One more question regarding the effects of climate change and the change of plant hardiness zones that come with them. Are there any species that are going to be less susceptible to Windthrow that we might want to consider planting going forward?
Well, yeah, and in that last slide about climate change, some of the work that's been done in terms of projecting future composition in our forests, including my own work, is that we expect to see an increase in the abundance of temperate, warm adaptive species such as maples and oaks, and those species tend to be more resistant to wind than some of our more northern species such as spruce, fir, and even in terms of hardwoods, poplar itself. And so that was one of the points I was trying to make the last going off, is that even if we do see a potential increase in the average amount of wind in this region, if tree species composition changes, also quick enough, as we're expected, well, then we may see a corresponding increase in these more wind adapted species, or these species that are less susceptible to blowdown, such as the maples and oaks, for instance, or even pine for that matter, white pine.
Good to know. Chris Spencer has a question. Chris, go ahead.
Yep, thank you. Great presentation, Anthony. Thank you, very timely.
Thank you.
One aspect that here in southern New Brunswick, along the coast and inland off the Bay of Fundy, that we're seem to be experiencing a lot more is snow loads in the wintertime. Along with climate change, I think that what we're finding, particularly in the south, in particular our managed stands, our snow loads are no longer, or less often, are what I'll call the traditional snow. When it's 20 below and the snowflakes nicely float to the ground. We're experiencing more and more mild days of snowfall and freezing events, and that, coupled with the increased wind patterns, is sort of a two-strike against our managed stands. And just wondering if you had anything to add to that, or is this something that might become more common further north into the province?
Yeah, that's an interesting observation, and there has been work done in New England in terms of understanding that coupled effect of wet snow load and wind combined, and obviously, just like you said, when you have those two forces combined, with not just a snow load but a heavy snow load due to the warmer temperatures, well then it's more gravity working on the tree, and even acts as a more resistance to the wind, so you can then have a greater wind applied force as well. So you could see how it could then lead to even more, if not like wind throw, at least branch breakage and stem damage and that sort of thing. So I think it's something that we're going to have to contend with. And then as the climate continues to warm, there's going to be a period of time where we go through more of this, and it's very likely that phenomenon will move northward. If you believe what the climate projections are telling us.
Yeah, we're down here. It's the frequency of wind events and extreme wind events. It seems to be becoming more and more common, and as practitioners, we're becoming more conscious of it, and we're really becoming a lot more conscious and being extremely more careful where we do partial interventions, partial treatments, because of the high risk of this ongoing problem.
And I think it's difficult for climate scientists and those using the climate data like myself to model the future. But I just think that anyone who's managing forests, a woodlot owner, or someone on a commercial scale, they really got to consider this. I pulled that slide back up again, that tug of war between the applied and resistant forces. And I guess everyone become more aware of what those forces are and how they could be alleviated. How can you alleviate that wind force, whether it be tighter stands, with tighter crowns, maybe more hardwood amongst your spruce, less thinning of your spruce, like those things will help alleviate that. And those are the types of things I think we need to become more aware of as we're managing our forest.
Well, just one last point. We've definitely seen the benefits of the mixed species, particularly the hardwood component. We find that it doesn't take a whole lot of well-rooted maple or pine or hemlock to firm up a stand, and there's certainly benefits to looking at the species diversity in your managed stand. And I'll stop there and say thank you again. Yeah,
that's interesting. Thanks for that.
Thanks, Chris. Bill Richards has a question. Did your analysis enable you to tease out the effective time of year? No leaves in winter on deciduous trees makes them more resilient.
Yes, that's a good point, and not in our particular case, no. And when you read through the literature on what factors influence wind throw, obviously time of year does play a big part in that. And in this particular study here, we just had data from that one wind event, which is Hurricane Juan, which occurred in September, and the leaves were on, and the soils were saturated too with water. And so, but you'd have to have the same type of data from different times of year to really tease out that effect of time of year on wind throw. And that's, if anything, from this talk, what I hope it encourages is more interest in this topic, because I focused heavy on Nova Scotia. That's just so happens where I've done a lot of this work. But I mean, the same sort of thing should be done in New Brunswick and PEI. You know, there should be more of it. And because I think it's an important disturbance that's going to become more important. And so we need to better understand these factors.
Very true. I also have a question from James Steenberg. First, he says, thanks for the great talk. And then his question also relates to winter and wind. Have you looked at any interactions of wind and winter length / severity, in particular winter and soils, such as the duration of winter where soils are frozen, there's freeze-thaw cycles, etc., and their interactions with wind disturbance under climate change?
No, I haven't. And I know James well. And well, there you go, James. That's a good research question for you and your group and the department down there to tackle. I mean, like, those are excellent questions. And I'm sure, like, if you, and maybe I have come across research that's been done in that area when you look through the literature. I can't recall off the top of my head right now, but those are like important questions to more fully understand, you know, like, how does wind affect our forests? You know, how does it affect the rates of windthrow? And I should say too, like, the rates of windthrow that I put up there today, like such as these rates that we came up with for hurricanes, you know, what we need to do in the provinces here in New Brunswick and Nova Scotia is, you know, when there are big storms like the Hurricane Juans or whatever, when they go through, we need to put more effort into quantifying the forest damage that occurs afterwards, you know, from the storms. And that would give us more data points to improve these estimates. Right now, this is the first attempt to do this in the region. And so they set a benchmark, but no doubt these could be adjusted, revised, or improved if we have more storms to follow up on. So it just, again, emphasizes or highlights the need for, you know, when these storms occur, whether it's a hurricane or extratropical cyclone, a nor'easter, how can we better quantify, map, you know, where the disturbance takes place, and then study that information.
Looks like he agrees. So we're running out of time. We're already at 2:58. I'm just going to check and see if there's anyone else that would like to ask a question. Oh, Bill Richards. Can you explain why the moderate severity windthrow is more frequent than the low severity windthrow?
Yeah, yeah. It's because when, like, those rates, we calculate it from this area here. So when Hurricane Juan went through, the province delineated this area because that's where the most damage took place in the province, and used detailed satellite information and aerial photography to tease out where the windthrow took place. And then we use just the information in this area to come up with these numbers. But no doubt when Hurricane Juan went through, there's probably more, especially like most of the high severity damage probably did occur in here, but there's probably a lot more low severity damage that resulting from Juan that occurred outside of that area. And so in the paper, actually, we allude to that this is probably a very minimum estimate, you know, of, or I should say maximum, I guess, in this case, of low severity windthrow. It's probably, the interval is much shorter than that. You know, if we had the data available outside of that area, you know, if we were able to quantify that, but unfortunately that's all the data that we had. And so again, it highlights the importance of, when these systems go through, these storms go through, we need to invest in, you know, surveying this stuff, so then we can better understand how it affects our forest. And if we're going to do things like ecological forestry or understand the effects of climate change, then this is the kind of information that we need to do that.
That's great. Well, we have run out of time for today. If anyone does have any further questions that they would like to ask, Anthony, you can be reached.
Yeah, I just put my email up here at the end. There's my email, and yes, I'd be happy to talk to anybody afterwards if they have questions, or lead them to better resources. And like I think Patricia was saying, that I believe the talk is going to be put up on the website. So.
Yes, it is. Okay. Well, Anthony, I really want to thank you for this presentation. It was very informative. And I'd also like to thank our translator, Ron Fournier, who's been simultaneously translating into French for us. And I want to thank everyone for participating in today's webinar. We hope you'll join us again for future webinars and project events. And if you have any questions, you can always send me an email nbfwo.project@gmail.com, or you can go to the Federation website, nbwoodlotowners.ca. Thanks, everybody, and have a great day.
Thank you.